Bismillahirrahmanirrahim. Assalamu alaikum students. Now in last lecture we are discussing triple products. We said that there are two kinds of triple products. One is triple scalar product, which was A dot B cross C. We explained that we said it is called scalar product because it is a scalar and geometrically it turned out to be the volume of a parallelepiped with ABC as three intersecting edges, right? Now, second kind of triple product is triple vector product. We'll explain that. Triple vector product. Triple because there are three vectors involved, and vector product because this yield is a vector. A cross B cross C. B cross C is a vector, so we cross that another vector A, the resultant quantity is a vector. You know cross product is a vector. You also know that if this is my B vector, this is my C vector, then B cross C vector, let me use another color. B cross C vector by definition is perpendicular to B and C both. In diagram, I show it this way. It's perpendicular to C. It is perpendicular to B both. Let's redirect it up like this, and we know how we find the direction of B cross C vector using right hand circle rule. Now using same idea to A cross B cross C. Treat this B cross C as a single vector, then A cross B cross C is perpendicular to A and B cross C, right? So this whole vector is perpendicular to both A and B cross C, right? Got it? I said B cross C vector is perpendicular to B and C. Similarly, A cross B cross C is this whole vector is perpendicular to both A and B cross C. Now, I am interested in this part that this is, I am interested in A cross B cross C is perpendicular to B cross C. Because I have to explain one thing that is connected to that part, right? So it's true that A cross B cross C is perpendicular to both A and B cross C. Now I'm taking this piece of this result that A cross B cross C is perpendicular to B cross C. If it is perpendicular to B cross C, it must lie in the plane formed by B and C. Only that way it can be perpendicular to B cross C, right? Because B and C are two vectors. B cross C perpendicular to the plane formed by them because it is perpendicular to both. So if A cross B cross C is perpendicular to B cross C, it will lie in the plane formed by B and C, right? So conclusion is A cross B cross C, use another color, lies in the plane of B and C, right? And if it lies in the plane of B and C, then it will be some combination of B and C. It will be some number A times B plus some other number B times C. Simple, don't get confused. For example, if some vector lies in xy plane, for example, some vector A, then we write this AXI plus AYJ, where I cap is the unit vector along x and j cap is the unit vector along y. We split this vector into I and j. X and ay are the numbers which scale, which get multiplied to I and j respectively. Similarly, I am saying since this vector lies in the plane of B and C, then it must be combination of B and C. That means it must be some number times B and some number times C. Now it turns out when we do the maths, it turns out that we are not doing that derivation or that maths, we're directly writing it. It turns out that A cross B cross C is equal, I said it is some number times B and some number times C. So that number here, that A, turns out to be A dot C. And this number here turns out to be A minus times A dot B, right? So A turns out to be A dot C and B turns out to be minus times A dot B. This result you need to remember. This is sometimes called back cab rule. This is sometimes called back cab rule. Why it is useful? See, it is converting cross product into dot product. In a way, here we have to calculate two cross products to get the answer. Here you have to calculate just two dot products. Dot product is easier to calculate than cross product, so it makes our life easy, right? So A cross B cross C is combination of B and C, and here you have A dot C, here you have minus A dot B. Now you can use this for any three vectors. For example, if I have C cross, let me use another symbol. If I have three vectors like D cross E cross F, right? Now apply this rule. What it will be equal to, rule is this vector will be perpendicular to E cross F. Therefore, this vector will lie in the plane of A and F. So it will be some number times E and some number times F. Now this number will be the dot product of other two, that is D and F, right? And F I have used in this term, so it will be dot product of other two, but minus times dot product of D and E, right? See, A was instead of D, let me do it this way. A was, or I use another color. A was instead of D here, so it will be instead of D here also. B is instead of E, so B is E, replace it by E. C is replaced by F, so C is also replaced by F here. A is replaced by D, right? B is replaced by E, and C is replaced by F, right? So whenever you have this kind of triple product, you use this property to simplify your calculation, right? So this is called back cab rule. I will give you a question on this. This is your homework 1. Then we will move forward. Question is, using A equal to 3I cap minus J cap plus K cap, B equal to I cap minus J cap, and C equal to minus I plus J plus 2K, verify what this back cap rule, that is A cross B cross C is equal to B C. Here I have A dot C. Here I have minus A dot B, right? Am I right? This is B and C. Here we have A dot C minus A dot B. A dot C minus A dot B, right? So I am giving you three vectors. You have to verify this. That means first you will calculate your left hand side, then you will calculate your right hand side. They must be equal. So this is homework 1. Now we will move to next topic. Our next topic is, let me use this color, Newton's laws of motion, right? You know, there are 3 laws of motion, right? So I will give statement. You know these statements. We have to discuss these laws. So first law, Newton's first law. What is the statement of this law? It says a body remains in a state of rest, in a state of rest or constant velocity which means zero acceleration, zero acceleration when no external force, when no external force acts upon acts upon it. That is, acceleration is zero when F is zero. I repeat, a body remains in a state of rest or constant velocity, that means zero acceleration, when no external force acts upon it, that is A is zero when F is zero, right? What's the meaning of this? For example, if there is a table and on this table there is some book. If there is no external force on it, when we say external force, that means some agent exerts force on it externally. Actually, when we say no external force acts on it, that means either there is no force on it or many forces are acting on it, which vectorially cancel out, right? So this no external force, sometimes we write no net external force. You need to keep that thing in mind. If there is no force on it or no net external force on it, if it is at rest, it will remain at rest. It is understood it is with respect to some other body, right? Or with respect to a coordinate system, right? So coordinate system will be chosen by some body, some observer. For example, that observer may be you. If you are before this table and you look at this book, you conclude that there is no external force on it, so it is at rest, it will remain at rest. If it is at rest with respect to you, it will remain at rest. Or if it is moving with some constant velocity, that means if some body is moving at some speed in some direction, constant velocity contains constant speed as well as constant direction of motion. So if there is a body which is going at some speed in certain direction and there is no force acting on it, it will continue to do so. Its speed will not change, its direction of motion will not change, right? So these are all incidences of acceleration. What is acceleration? Rate of change of velocity. So if velocity changes, acceleration is produced. Now if a body comes from rest to motion, that is acceleration. If it is moving at some speed, its speed changes, that is acceleration. If it is already moving at speed, if it slows down, that is acceleration in negative sense. And if it is changing its direction of motion, that is also acceleration. Since acceleration is rate of change of velocity, whenever velocity changes, acceleration is produced. Whether it changes due to change in direction of motion, or it changes due to change in speed, or it changes due to change in both speed and direction of motion, all are instances of acceleration. So we can simply say that if net external force on a body is zero, its acceleration is zero. That embodies all this statement, right? So this is Newton's first law. Now, what is Newton's second law? Newton's second law of motion. I will give you the statement. Newton's second law of motion says, use this color, the rate of change of momentum of a body, the rate of change of momentum of a body is proportional to is proportional to the force on the body. The force on the body. Now the momentum, momentum is defined as mv product, where m is the mass and v vector is the velocity, right? The statement is the rate of change of momentum of a body is proportional to the force on the body. Momentum we define as mv product, where m is mass and v is velocity. So sometimes we denote momentum by p. The momentum is a vector quantity. The body is at rest, its momentum is zero. If it is moving at some velocity, it has certain momentum. Its SI unit will be kg meter per second, right? Mass is kg. In SI system, V is expressed in or measured in meters per second. It is a vector quantity, and this vector quantity is similarly directed as velocity. This mass is a positive scalar. Positive scalar times a vector yields a vector in the same direction. So let us come to this law. This was the definition of momentum. So this result is saying rate of change of momentum of a body is proportional to the force. That means if you double the force on the body, its rate of change of momentum will double. If you triple the force, rate of change of momentum will triple. That means F is directly proportional to how we write rate of change of momentum. We use the derivative d by dt of, I will use a different color, of what? M v. And v is the momentum of the body. So F is the force on the body. So Newton's second law says it is proportional to the rate of change of momentum. That means if momentum changes rapidly, then there must be larger force acting on a body. If momentum changes at lesser rate, then smaller force is acting on the body, right? Or you can say in reverse that to increase the momentum of a body at a greater rate, we need to apply large force. To increase the or change the momentum of a body at a smaller rate, we need to apply smaller force. And by doubling, uh, if you double the rate of change of momentum, force required is doubled. If you triple it, force required is triple. That is the meaning of proportionality. So we write or F is equal to K times d by dt of mv, where K is constant of proportionality. Then we can write it K m d by dt of v. Now here I have taken m outside the time derivative. That means I have assumed m is a constant. So here I am assuming m is constant in time. The derivative is with respect to time. I am assuming m is constant in time. That means mass of the body is not changing with time, right? Then what we do to this k, we choose our units so that k is 1. We choose our units so that k is 1. How? In SI system, in SI system, International System of Units, M is measured in kilograms, kg. A is measured in meters, in meters per second square, and F is measured in Newton. We say when m is 1, right? I can write here the step K M A, because the rate of change of velocity is acceleration. So coming back to making K1, we say when m is 1 kg and its acceleration is 1 meter per second square, then that much force we call 1 Newton. Right hand side, this thing is 1, this thing becomes 1, the ratio becomes 1. So we make by our choice of units K1. I repeat, we say when 1 m is 1 kg and it is accelerated at 1 meter per second square, then force experience or force acting on the body is called 1 Newton. So K becomes 1, right? So then we write simply F is d by dt. It is vector here. Let me write it in vector. Here I have a vector. My right hand side is a vector, so it's vector. Here I have a vector, so I write F is d by dt of mv. So this is my Newton's second law. Now see, I said that here I have assumed m is not changing with time. Now here I am writing m inside time derivative, right? And if m is not changing with time, that means its derivative is 0. Only then f is, then I should write, then f is ma. When you write it ma, a is dv by dt, so you are taking m outside the time derivative. That means you are treating it as constant, right? So if a general way of writing this Newton's second law is F is equal to d by dt of mv. When you write it as F is equal to ma, then you are assuming this thing. We need to keep this thing in mind. When we write F is equal to ma as Newton's second law statement, we're assuming that mass of the body is not changing with time. Here, derivative mass is inside the derivative, time derivative. So here we don't have that restriction, right? So when we have to take into consideration the variation of mass with time, for example, when velocity of the body is close or comparable to speed of light, or comparable to speed of light c in vacuum, in that situation or in those situations, mass changes with time. So you must write Newton's second law this way. You cannot write that Newton's second law as F is equal to ma, right? But if we are in non-relativistic limit, non-relativistic limit, this is relativistic limit. Non-relativistic limit means if the speed of the body is smaller than the speed of light, very, very smaller than the speed of light in vacuum, then its mass is constant. So these two expressions are equivalent, right? This was my Newton's second law. I think I should give you some homework now. Yes. So you have a question. Question 2. One homework I have already given you. This is question 2. Question is given two vectors such that a plus b is equal to 11 I cap minus j cap plus 5k cap and a minus b is equal to minus 5 I cap plus 11 j cap plus 9k cap and part A, find A and B. Part B, find the angle included between A and plus B using vector methods. I repeat the question. Given two vectors such that A plus B is equal to 11 I cap minus j cap plus 5k cap and A minus B is minus 5 I cap plus 11 j cap plus 9k cap. Find A and B. Find the angle included between A and A plus B using vector methods. That's all for today. Do your homework. Don't waste your time. Thank you. God bless you. Assalamu alaikum.